Hello everyone, good morning, good afternoon, and good evening. So, today we are going to see how we can convert our monolithic LabVIEW application into simple microservices. So, we can going to see a LabVIEW journey here. And so, myself, I'm Shankar Muthusangu. I'm currently working as a senior lead engineer at Value, a global leader in automobile technology. So I have 12 plus years experience of developing software and test solution across various industries. So all these 12 years I'm working in LabVIEW only. And so my domain expertise is end of line testing, vision based quality inspection, and automated test system. And I have contributed to various industries, including the automotive, medical devices, defense system, and industrial automation. So here in Value, my focus is I'm leading development of advanced test solutions for validating automotive components and systems, ensuring performance safety and compliance. Yeah.
So, hi everyone. So, my name is Sriram Gopalan, and I'm currently working as a senior research and development engineer at Value. So, I have around 13 years of experience in software and test solutions. And of late, I have also specialized myself in generative AI with cloud along with the automated test system. So, at Value, I focus on the development of GNA based solutions for test automation and also the development and architecting of distributed applications. So we'll move on to this subject today, where the core idea is how we can transform the LabVIEW application from monolithic client to agile microservice. So yeah, when we take the software development, it is a very creative field, right? So every application is unique in nature. So we see applications of various complexities. So some are CPU intensive tasks, some are data intensive, and many are of it they are very IO based operations task. So with the advent of more open source, so we see a lot of emergence of libraries and tools. There are tons of programming languages. There are tons of design patterns and algorithms that comes into picture. So the list goes on and on. So as a developer, it is very overwhelming to really understand the different things which is there in the computer science. So the core thing of any application, however, remains same in software development. The tackling the complexity of the application. So how you do you tackle the complexity? So that's the major question. Anyone has a that's the good question to ask actually. How we can tackle the complexity? So the answer is pretty much same for many years. Actually, it is universal. Like you have to decompose the software to reusable modules, and LabVIEW has always encouraged us to develop reusable modules from the beginning. And even the certification exams like CLD or CLA, they highly encourage that aspect actually. So this is perfectly fine if your application is only within the ecosystem of NI. You could develop the applications with the reusable modules by utilizing either your own custom one, or you can use some of the design patterns like state machines or DQMH frameworks or Actor. So this works perfectly fine within the ecosystem of NI. However, like I mentioned, the software field is creative, so we are not only limited to utilizing only NI. There are a lot of tool which is emerging every day. So naturally the applications which we tend to develop is not only limited to LabVIEW. So we get to a point where we develop an application where LabVIEW is part of it rather than uh, the usual approach where we develop one full application fully wholly in LabVIEW actually. So that's where the distributed applications they come into picture actually. So whenever LabVIEW is part of your whole application, designing it proper distributed way is a right thing to do. So here we are going to tell you a story, and we are going to explain how this actually perfectly fits along with the demo actually. So the story begins here. So we can imagine a developer. So we have met Sarah here, and she is primarily a LabVIEW developer, and she starts with a simple application of data acquisition, and this is what NI is very strong and supportive on. So her application is very simple in the beginning, but what happens over the period of time is the complexity adds unknowingly. So what started as a 50 plus VI project, it could really turn easily into a 500 plus big monster. So most of the applications which we would have developed earlier in LabVIEW, it would have been monolith. It would have been one single large applications. And of course, we would have seen all this problem where between the modules they have been tightly coupled, and we always try to deploy it as a one single executable. So those are the challenges which you would normally see in the monolith. Yes. And what it leads is some of the nightmare scenarios. So you have to uh, do an update, which is where you have to rebuild the whole application even for a small changes. And even for the scaling, you have to really work on it. And when the application is large, you will have teams of developer, and if many people are working on the same project, it becomes a really a team chores. So there are a couple of problems and scenarios which you can see in this slide, where it is very difficult when you always tend to develop the application in the monolith way. And LabVIEW being one of the tool is it's although it offers integration with other external tools, but there are things like where the management expects to have a dashboard in JavaScript. And of course, with the advent of AI, everyone would like to use AI-based solution to our project as well. So the there is no single tool which can give you all the facilities. So the only way what we have to do is we have to stitch together all the right tools, and we have to make it a usable product. So this is the overhead which happens, and the growing demands is as much as in today's world is cross language integration. So we need tools which is there in the market, and we have to link it actually. So like I said, we have to stitch all those things to make it a usable tool. It's not just one tool in the end actually. So you can have a good web application from Java, and you can leverage the cloud, and you will also would have a need of using the AI based application. So this is the approach which is common in last few years, especially in the post COVID era. So the question which everyone has is like, how can you integrate, those part with LabVIEW, and LabVIEW must be doing its core job in a very successful way. So this is the question everyone tends to ask actually. So how can you make LabVIEW as one of the service which can talk to other services?
Yeah. So here is the game changer. And so new hopes arrives for Sarah. At a conference, Sarah discovered a microservice architecture, the solution to her monolithic madness. So what is microservice? What are the microservices? So microservices are a small independent services. It's a single responsibility principle. One service will have only one job. So if you have a data acquisition service, it will acquire only data acquisition. The logging service will only log the data, and it's loosely coupled. So you can connect the data logger service to any other service, and logger service to the analyzing service, something like that. And you can deploy the each service independently. And this microservice the way it's language and technology agnostic. And so to talk to the external world, to talk to the Python world or JavaScript world, we need some approach. And Sarah discovers three magical bridges to communicate with other worlds like Python world or JavaScript world. And those three approaches are REST, gRPC, and NATS. So first, the REST is the universal language which works with everything, and gRPC. So gRPC, it's the speed demon. So it has high performance, and we can stream the large amount of data using the gRPC protocol. And then comes the NATS. So NATS is the message whisperer. So it can used as a like message sharing service, and it's a language agnostic messaging. So both all these three approaches promise the polyglot uh, way. So we using these three approach, we can communicate with the Python, JavaScript, C Sharp, Java, Go, and all other open source languages. So with this microservice approach, so Saros, the previous problems all get resolved, like the update catastrophe gets isolated update. Now you can update the each service without disturbing the other one. Like you can update the sensor service without touching the UI, and it increase the independent deployment cycle. And the scaling nightmare turns into the selective scaling. So you can scale only what service need maximum CPU or maximum GPU, something like that. And so the team chaos turns into parallel development. Each team owns their service and clear API boundaries. So they can define their API boundaries, how they are going to talk with each services. And then deployment drama to rolling updates. So with this, the Sarah achieved the zero downtime updates, and they can now she can deploy the service individually. And integration isolation to the polyglot architecture. So now Sarah can use Python for AI/ML alongside LabVIEW hardware, and she can use the React and React.js dashboards with the LabVIEW drivers. And now she can use the best tool for each job. And we can see how Sarah is happy using the microservice. And you can see Sarah's angry face on the monolithic world. And we'll take a one problem, uh, and how Sarah used these three bridges to connect with the LabVIEW to the Python. So the problem statement is this. So Sarah wants to develop a predictive maintenance system that integrates LabVIEW based data acquisition with Python based machine learning models. Okay. The goal is to accurately predict when a machine will require service based on the real-time sensor data. So we'll see how these three approaches can be applied on this scenario. Let me. So on all these three scenarios, okay. So all these three scenarios, the lab is going to act as a server, and the Python is going to act as a client. And so the Python side, I'm not going to do anything. So I will going to demonstrate how we can develop mm, the LabVIEW server. Okay. Give me a minute. So first comes the REST, the universal bridge. So Chara chose REST first. It's like the universal language everyone speaks. So what is REST in LabVIEW context? So REST is nothing but a HTTP based communication. So almost all the language has this HTTP library by default. And the data exchange between the server and client is mostly on the JSON data exchange. And this is the standard web protocols. So if you if you want to use any JavaScript dashboard, you can go with this, and it's a platform independent. Okay, and we'll see a small demo of REST, how the Sarah achieved. Sarah solved her problem using this REST. So first I will open a okay, LabVIEW is opening. Give me a minute. So yeah, so here we have the LabVIEW startup page. So first I'm going to create a new blank project. So here we are going to create our REST based server. So to create the REST based server, I need to add the web service on my LabVIEW project. So I have added this web service in my LabVIEW project. I'm going to rename it into the sensor. And here I have two virtual folders. So here in the startup phase, I can implement logic, what I need to do when the REST server starts. And in the web resources, I can specify the REST endpoints. Okay, so first I'm going to add one new VI here. And so here what we are going to do is, so here what we are going to do is, uh, we are going to generate a random number, so which will give the current information. I'm going to generate a random number, so which will be in between of 4 to 20 milliamps. So my upper bound is 20 and my lower bound is 4. And this is my current output. Milliamps. So that's it. Actually, this is a very simple implementation. For the demo, we have used this random number. And in the real time, you can use some of the communication protocols which can communicate with your actual data acquisition system and get the data and uh, send it to this VI, and you can display that here in the user interface. And I have to connect this the indicator into my the connector pane to display the data in the JSON structure. I'm going to save this. Yeah, I'll go to REST. So this is my same current PI. Yes, let's get saved. And I have to save the project as well. This demo. Yeah, it's get saved. And so you can choose whatever method you want. Like in the rest, we have these four methods: get, post, put, and delete. So each method has its own purpose. So for example, here we have the simple request, like we need to get the data of the sensor. So we can use this get method, and you can configure this REST endpoint properties. Not here. I think here. Okay, so here we have the current.vi, and you can see, so this is our URL mapping, and so you can specify which method you want and what is the output type. So these are all the output types supported by the LabVIEW web service. So we'll usually go with this JSON format. That's it. And I will start this server now. I'll start the debug server. Okay, now the server is started. So I can get this URL for this endpoint, and this is the endpoint for my URL. I can go and open my browser and check this endpoint is working fine. Okay, I need to close this window to get the output. Yeah. So now you can see for each API hit, I can get a current value. So this is my URL. Now you can see this. Mm, yeah, yeah. So here I have this endpoint. I'm just replacing this, maybe some typo. Yeah. So I'm going to fetch the data from this endpoint for 200 millisecond, and I'm going to take the 100 points. And so here we are not doing any machine learning or the predictive maintenance. What we are going to do is we are just getting the data from the LabVIEW and plotting in it in a matplot for the simplicity. Okay. So first, now our server is running. I'm going to run this client. Yeah. So now you can see it's getting the data from the LabVIEW and plotting it in the Python math plot. Okay. So this is the plot. So instead of plot, I can implement my predictive algorithm here, and I can predict when the machine needs service or when it fails. So this is how Sarah solved her problem using the REST approach, and we'll see what are the advantages and disadvantages of REST approach. So these are all the some of the advantages and disadvantages of the REST. So the advantages, it's a universal language. So as I said earlier, all the programming languages have this HTTP library. So it's very simple and easy to use. And so we are using the human readable JSON format to send the to the serialization. So it's very easy for everyone to understand what data it's going and what is coming. And it's firewall friendly, and it's a perfect for polyglot architecture because REST is supported for almost all languages. And we can also do the open API standard development here. And what are the disadvantages using REST? So here we have the higher latency overhead, and we don't have any built-in streaming methods. So we cannot send the high data to this REST-based approach. And for the simple messaging, we have HTTP overhead for small messages. Each service should run, and the one major problem is, so each service should run on the different ports. So if you are running 10 microservice, you need 10 different ports. If you are running 100 microservice, you need 100 different ports. Okay. And so when we can use this REST-based approach. So if you want to use the dashboard, web dashboard, which is developed in JavaScript and React, you can use this. And AML integration with Python, you can use this. And enterprise system integration, like with the .NET or Java, you can use this approach in mobile app background and third-party API integration. Also, you can use this REST-based approach. Then comes this speed demon, grpc. So grpc is the performance powerhouse. So what is grpc? So grpc is the Google's high performance rpc network. So it uses a protobuf files to serialization, and so it based on the http slash 2 based approach. And grpc is the strongly typed contracts. So we will see how Sarah used grpc to solve her the previous problem. Okay, so here I'll open, I'll close this one, and I'll create a new project. Okay, I'll save this project now. And so we have a tool which is comes with the grpc, which can generate our server as well as grpc server as well as grpc client. So I'm going to launch that tool. So yeah, so this is the tool. uh, yeah. Okay, so this is the tool which can be used to generate our client as well as the server. And the grpc protocol is based on the protobuf, as I mentioned earlier. So we'll see what are the protobuf. What is the protobuf? Let me go here. So protobuf is nothing but a text-based file, and it is used for serialization and deserialization purpose, which is also this standard is developed by Google, and the same standard is used for the gRPC serialization. So it has the service name. So we have this service, sensor service, and it has one endpoint which is nothing but the get current. And for the get current, we have this request uh, and this response. Okay, so this request has the sensor ID, and the response has the current in milliamps. And you have to specify the data type of this each the variables you are going to pass with the request, and each variable you are going to get with the response. So this is a simple file which will define your service and what is the input and what is the output. Okay, so I'm going to give this give input to my server generation. So I'm going to select this file here.
Select.
Hmm. So now I have selected the file here. The target name, target project I need to select, which is my demo 3 grpc project. I think that's it. You can provide all other information to customize the generation, but this default information is enough. And what I'm going to generate is the gRPC server, and you can generate if you want. You can generate client and both. So I'm going to run this. So it will close the project and it will generate the gRPC server, and can open it again. Yeah. So it's done the generation. So now the grp server is generated here. Okay. So first we need to, so this is the server VI. So first we need to replace this cluster with our cluster, our class. And I need to open, so this is the uh, VI. When we get the request, this will be get executed. I think something went wrong here. Generated. Sorry, we'll generate again this server. Let me close it again. Close it. And I will generate. Six. And just create the folder alone now. And run again. Let's see. This time it we can generate correctly. Actually, it's messed up with the previous demo, I believe. Yeah. So we have. Correct. Let's see. Okay. Yeah, you're right. Yeah, I think my proto file is wrong. That's why. Let me generate again. Yeah, I think it's generated now. Yeah. Okay, fine. It has this frame service as well, but we don't need that now. So I can open this front service.vi and so here. So we'll go a little quick because we don't have much time now. So I will replace this with my sensor service. Okay. So here we have this while loop. with event structure. So when the client requesting the current, this event structure will get executed, and we'll have this grpc id. So this is the request id, and in the server side you can see these two VIs, get and set. So using this message ID, we can get what are the sensor information they request, and we can set the data of that sensor information. So for example, here in our case, we have only one sensor, which is the current sensor. So we don't need this get sensor request. I'm going to use this set current only, set output only, and I'm going to connect here. And similar to the rest, I'm going to implement the random number here. So it's 20. It's 4. My lower limit is 4. Yeah, this is going to here. And that's it. So now our server side code is completed. Let me close this and close this and run this service. So I can run this service in any port. So now I choose this default port 551. So now our service is running successfully. Let me go and open my. Yeah. So my Python client, and I will run this client. So here you can see the gRPC server and what is the fetching intro and maximum point. It's similar to the rest, and it's fetching the data from the LabVIEW server using the gRPC protocol and plotting it in the graph, similar to the rest. Yeah. So this is the another approach we can use with REST and LabVIEW. And again, I'll go to the presentation. We can see what are the advantages and disadvantages of. Okay. So it's a high performance and so yeah. So it's a high performance cross language communication. So it's especially built in for the streaming, the high data streaming, and so it's a very fast compared to REST. This gRPC is very fast. It's because it's advanced one, advanced protocol, and it's perfect for polyglot and real time system. And we can do the bi-directional streaming as well using the gRPC. And so these are the some of the disadvantages we have. The it's more complex, and so if you want to use the real-time control with the LabVIEW and Python, we can. It's good to go with gRPC. And the next one is NATS. So NATS, it's an event-driven messenger. Sarah's distributed sensors needs to gossip with each other effectively. So Sarah choose this NATS approach. So NATS, it's a lightweight messaging system, publish and subscribe pattern, and we also have the request reply messaging pattern as well, and it supports a cloud native and very simple to implement. And we can go to the demo quickly. I'll close this as well. Yeah. So can do it very quickly, I believe. Let me go and create a new VI. So uh, the NATS comes with its library. So you can find this library in the GitHub. I'll share the link. We have to initialize the client, and we need to connect the client, and then we can publish the message. So then we can disconnect the client. That's it. Let me connect here, here, and here. I have to provide some of the informations here. Yeah. The connection string. So you can configure the client, but I'm just now I'm configuring it, everything is default. Constant. Connecting just to here, and I'm going to use this window. So every 100 millisecond I'm going to publish this, and the NATS it's based on the topic. It's publishing the data using the PubSub model. So each PubSub model will have the topic. So like the gRPC or the NATS, we don't have the any ports here. We'll have the topic, and with the topic we can talk to each other. So here I'm going to provide my topic, which is nothing but subject. So sensor dot current. So this is my topic now, and similar to other implementation, I'm going to use the same random generation. And use this. Chunky, and I have to convert this into JSON. So I'll use cluster here. That's it. And to JSON. So this click convert here. Let me make it bigger. And so this is my payload. I think that's it. Simple. Now our server side is ready. So uh, in NATS we need the message broker. So for that I'm going to start my NATS server. Okay, it's started now. I'm going to run my this LabVIEW client as well as my client in Python. This, yeah, this one. So this is the NATS URL portal, and this is my subject. I'm going to run here. So you can see here, it's similar to other approaches. We can get the data from LabVIEW to Python using, now we are using the NATS. That's it. Okay, I'll start this.
So I think with this we have seen the uh, demonstration on with how we have done with respect to REST and how we have done with gRPC, and last one is NATS. So among these two, I think the REST and gRPC are considered as a standard, and NATS is something like it's a PubSub model, and among the PubSub model, it is widely getting popular. But right now, it is not certainly a standard which is much recognized like REST and gRPC. So this is a decision matrix which can choose when you are trying to develop a distributed based application with other language. So when it comes to language support, I think REST, gRPC, and NATS, all three, they have an excellent language support. And for the ease of implementation, so when you're starting with a POC or a simpler projects, REST is preferable. But if the application has some performance bottlenecks, I would say gRPC is recommended. But if you have a lot of applications and you want to, you're not bothered about the bottlenecks, I would say NATS is much more preferable even than the REST and gRPC. Actually. And in terms of performance, I think the gRPC stands way ahead, but still NATS and REST, they are good for some most of the applications generally. And real-time capability is again, I would say gRPC is much more efficient and speed compared to REST and NATS. And the application, if it teaches the web integration, you have to consider REST actually in this case. So I think with this, I think you can develop a good distributed application with varieties of languages, and you can pick any of these three, and you can uh, develop a good distributed application in quicker time. So I think that concludes our demo, and thank you for giving us the opportunity here. Thank you.
Thank you all. Yeah.
So if you have any questions, you can ask me.
Okay. So if you don't have any question, I think we can close this session.
Okay, and I think there are two questions here. So can gRPC communication be encrypted in LabVIEW?
Communication. Actually, gRPC communication, it's already encrypted using this protobuf file, Eric. So I think, yeah, we can use the encrypted for in LabVIEW. And the second question is, in your experience with all these web services you are test starting, it is necessary to understand the underlying technologies in order to troubleshoot, or its knowledge of lab is sufficient?
Okay. Okay, so like I already told, the when you are developing only within the LabVIEW ecosystem, you don't need to consider the underlying technologies of which is there outside actually. But when it is a cross-platform application where multiple languages come into picture, so at least an idea of what the tools is essential actually. It need not be 100% in depth, but at least an overall high-level knowledge is essential actually to develop. Okay,
Okay,
thank you.
thank you.